And this is a follow-up video for the Ace Pro Teardown and Assembly. And this video covers a lot. But before we do, please hit that like and sub. Thank you. And we begin with these two screws over here, where we look for the feeding mechanism and the filament sensor. I felt the need to make another follow-up video for the Ace Pro because there's a lot of people in the Facebook groups who have been having trouble with the Ace unit, and I get it. It's very frustrating to be in that situation. Be careful removing this plastic part because you can definitely snap it off. Just enough wiggle and force should be enough. With this guide, this picks up the in-depth tutorial on how to disassemble it. So we lock up the unit and flip it over here. And there's around 6 screws we do need to remove on the bottom part, which I do point out over there. And the other 2 are at the bottom of these rubber feet over there. Disassembling the Ace unit can be time consuming. And good thing I had an extra pair of hands to help me around. Here's the rubber feet. We then proceed with unscrewing the hidden screws. We do this so that we can unmount the inner assembly of the Ace unit. If you think the pace of the video is too fast or too slow, feel free to adjust the video. Now, my Ace Pro didn't have any problems. I just wanted to help out the community, and basically my way of giving back from all of the years I've been 3D printing. 12 good years of 3D printing, and I'm still amused. Crazy. Anyways, we continue with removing these 4 screws, which I did point out earlier. You do this so that when we do remove the inner assembly, there's nothing stopping it from being completely detached from the housing cover. We then proceed with removing the buffer mechanism cover over here. And while we're doing this, do make sure you have a plastic container. You can store all of the screws and covers because a lot of these things can be confusing to get back. You don't want an extra screw or a missing screw. Next thing you know, you don't have a working unit, so avoid that. Yep. We then prepare the Ace unit because we'll need to separate the inner assembly and the housing cover. And this one took a while, so I had like a few cuts before we finally got to this point right here. It definitely wants a certain angle so that you can slowly remove the inner assembly, and voila! One whole piece separated from the housing cover over there. And in this part, I'll show you the stepper motor, which is very much responsible with feeding your filaments through the PTFE tubes at the back. And here we get to see a glance of what it's like underneath. In this part, there are 8 screws we do have to remove. I point them out right here. One's on the side and one is behind over there. So just follow the video on where the exact spots are and take your time. I have to say, being in this situation, it makes you wonder why you're actually disassembling the unit and how difficult it can be. So basically, if I didn't have the experience of disassembling 3D printers, I would be crying right now. But don't worry, we can fix it. And while we're waiting for this part, what made you buy the Kobra S1? I know mine was the price point. And it's crazy for me to see people either love or hate the Kobra S1. There's not an in-between. And, you know, all opinions and experiences are fair and valid, so I get it. How about you? Do you have anything to say about the Kobra S1? Comment down below. While that's happening, I'm removing the stepper motor one by one so that we're not overwhelmed with the disassembly. And keep note of the tension on the belt before you do release the mounting screws. This will be important so that when you do reassemble everything, you need the same tension as from before disassembling the Ace unit. Now be careful with this one because snapping that closed loop belt can leave you to weeks of waiting for this spare part. In my case, I did unscrew the plastic lock. It's called the bearing pressure plate on the Anycubic wiki. So you can see it loosen down the one underneath there, like the one moving. Don't worry, I'll show you on the next shot of disassembling the bearing pressure plate. So it's basically just a plastic part. I just did it in a different order so that the flow would be a bit better to understand. We then proceed with the other stepper motor. So the hidden screws are over there on the tiny gap. Not the best shot, but you'll be able to find it. Also a reminder to check the right tension on the closed loop belt. And it needs to be the same so that the filament can feed properly. Usually when it comes to the Ace Pro, things I've noticed about it is probably the filament sensor is the most buggy one out of everything, or the buffer mechanism. But in any case, you do have a faulty filament sensor, you can just follow this guide on how to open up the unit itself. This screw is with the nylock, so that's meant for the stepper motor. And the stepper motors have different mounts, so you're not supposed to mix them up. Here's another visual of where they're supposed to go. And for the left one there, which has the front and the back plates, right over there, and perfect. So now we'll be flipping it back up again. And I did something in advance, which I will be showing you on the next shot. Oh, look, the bearing fell off there. That shouldn't happen in your case because we do have to remove these pressure plates on the Ace Pro. But before we do need to remove the filament sensor board. So the one I'm pointing at are the mounting screws for this said filament sensor. It was actually hard for me to edit this video because I had the choice of cutting out the part so that it's a bit more faster, but also on the other hand, I might as well take my time to show you guys how to unscrew the stuff because the edit might be too fast. It might ruin the flow of disassembling the unit and putting it back together. So apologies again if this video is too long, but you know, it's kind of needed as well. Now we have access to the filament sensor and the PCB I'm pointing out. That's the one responsible with detecting the filament inside of it. And be particular with what number is associated with what board because it can be confusing. What I did here is I put it on the side there. We'll now be inspecting the main idler and driving wheel. And most often than not, there's usually a stuck filament around these parts. Something loose, something that's not supposed to be in there. So what you're looking for here and what I'm pointing out is how the filament is going in these slots over here. So there's a particular timing on this idler pulley assembly, which, you know, sometimes there is something loose in there, sometimes there's not, and most often than not, you just need to tighten a screw in the assembly itself. It really depends on what the problem is in your Ace unit, and you know, in this case, I'm just showing you how to do a rundown or teardown of it. And what I'm doing right now, I'm just removing the main connector from this breakout PCB. I think it's a breakout PCB, not entirely sure, but you have to be careful with this. I actually broke off one of the female connectors and that plastic part is done. That red part over there is a glue of some sorts, and now we proceed with unmounting the PCB over here. Showing you guys what it looks like, but a closer inspection would indicate if the sensor itself is faulty or if it's something else in the Ace Pro. I'm just checking if there's any stuck filament inside. That's why I wanted to show you guys the hole over there. And over time, it will be damaged because this is a plastic part. So if you're using abrasive filaments, it will tear down this plastic bit. I've seen horror stories on the Facebook group where, you know, over a few kilos of abrasive filaments, the plastic parts on the Ace unit does grind off eventually. And I'm pointing out the pressure plates that we do need to remove. So these pressure plates basically hold the bearings that are supposed to hold the idler pulley and drive wheel bearings. And if you're wondering why the inner shell is back into the cover again, I did this in a different order so that it would make sense in this flow of the video. You don't have to put back the inner assembly back into the cover. That's completely fine. I'm showing you the pressure plates that we do remove. So there's a bunch of these parts. Just put these on the side. And we continue with the other parts of the pressure plates. And while we're waiting, hit that like and sub. It really did help a lot last video. So yeah, thank you guys for the support. I'm really glad I've been making content like this, and this one deepens my understanding of how printers work, which is nice, and hopefully you guys pick something up from that. We have the final piece over here, 2 screws, put it on the side. I'm actually surprised with how much bearings there are in this idler and drive wheel. There's a total of 8 bearings we do have to keep note of. You could see me struggle here because I wasn't able to remove the stepper motor, which I did in the wrong flow. So don't follow what I did here. In the flow of the video, I do remove the inner shell first, and then we proceed with removing the drive wheel and the idler pulley. With some editing magic, here we have the inner shell outside of the cover again, and we can proceed further with the normal instructions like on the Anycubic wiki. So you can pair this along with the Anycubic wiki. It does tell you how to do this in a certain order, and you can use this video guide basically to help you along with disassembling the Ace unit. And it can be really daunting to open up this Ace unit, and that's pretty much the reason why I made this video, so that you guys can follow along and take your time with disassembling, so that hopefully nothing breaks and you can learn something from disassembling the unit itself and how it really works, how the jams go through from filament to the tubes to the extruder and the hot end side of things. So I'm just double checking the driving wheel there, making sure there's no loose screws there, and bearings are completely working fine. And so I carefully remove the idler pulley assembly. This part right here is responsible for selecting the filaments so that it can engage and disengage certain slots into the Ace Pro. So if you're ever curious on why sometimes when you feed slot number 1, number 3 goes out in there too, just moving just a little bit, it could also mean there's a misalignment in there where, you know, you can basically fix it by removing this and putting it back in the correct position. Something I noticed in my disassembly is I should have removed the shift dial first, because you can damage the sensor or the dial itself. And we're basically counter checking the filament sensor. So that thing over there is responsible with the timing. And if you have the shift dial a bit on the wrong position, it can select the filaments wrong, in the wrong order, I mean. And so we continue with inspecting the idler pulley assembly. We can see some of the bearings over there, pointing out that one. So that needs to be in the correct position when we do reassemble the piece. And hopefully you guys can find something out of this. So we'll try to remove the shift dial too. What I did was in the wrong order. So you needed to remove the shift dial first, right? And then just counter checking, you know, if it's rigid enough, if you have a bent shaft or rod. There's a lot of things that you need to, you can check out on this one. And in my case, everything was fine. Here's the closed loop belt and some of these parts, like the timing pulley and the custom idler assembly itself. So there's that. We'll proceed with removing the shift dial over here. So just remember that when you remove the shift dial, look for the flat spot, because that is the correct position to get the shift dial out and put it back together when we do need to reassemble a thing. This will be easier for us to reassemble the idler pulley assembly. And it was a bit confusing. I had to like double check it with the Anycubic wiki. If you didn't check the Anycubic wiki, you'd be really lost at this point, which we're trying to avoid basically with this video guide. And at this point, we pretty much tried to reassemble the unit. This is assuming we've already found what was causing our issues with the Ace unit, and any other part we did need to replace at this point, because we have pretty much full access to the inside shell of the Ace. And I'm trying to look for the flat spot so that I can insert the shift dial over there, but apparently I inserted in the reverse order, so kindly double check that. I'll remove this piece again and reinsert it in the right position. So removing it right here and then flipping it and then putting it back in, because if you didn't put this back in that orientation, it would not trigger the filament sensor or the sensor attached to it, to the shift dial. Now finally, this preps us to the screwing of the shift dial. And yeah, pretty much if Anycubic did send you any instructions to replace a certain part, you can follow the Anycubic wiki or follow this video guide, whichever works. Honestly, I'm just trying to help you guys out, and hopefully I can learn something from you guys too, because doing this alone is very much a hard thing to do. So it's mostly like a community effort. And yeah, if you guys want to like join my Discord, there's a link down below in the description, so that, let's say for example, you follow the guide and you know something's still wrong with your printer, I can probably help you out. Right now we're checking how it rotates on the shaft right there with the bearings on the mounting points. So it looks like it's been rotating fine, and pretty much we continue with assembling the unit. So right now we'll be proceeding with the drive wheel over here. Nothing was loose on mine, so that's perfect. And sometimes they do loosen out the grub screws over there, but making sure the closed loop is in the right position there, inserting it carefully. So yeah, like having an extra pair of hands here is very useful. And if you're doing this alone, you can feel free to pause the video and go back through certain parts which did take you a bit longer. Completely fine doing that. And I'm doing the same thing with the main idler pulley assembly. I'm rotating the drive wheel there, and it has been freely moving, which is good. Now we proceed with screwing the pressure plates again, which we did disassemble earlier. So those are the things we need. Grab the screws, and there's so many screws in this assembly and disassembly. It actually caught me off guard when I did remove the Ace Pro. I did not expect this much screws when I went inside the buffer mechanism, because it was pretty much still countable, but if you combine the screws from the buffer mechanism and the drive shaft here, there's so much to go through. But yeah, essentially we make sure that everything is snug tight, working perfectly, rotating fine, and picking up the filament properly as well. So double checking the bearings again, the position, everything seems a-okay, and rotate it once again. So there's a bit of force when I did rotate the main assembly. That's okay. So I only mounted 2 and then flipped it over, mainly because I wanted to mount the stepper motor first so that I can fix the right tension. And then when the tension is right, I do the final piece of pressure plates on the bearings itself, so that I can assure myself that, you know, assembling the stepper motor with the right belt tension is in there. Now, I don't know exactly if there's a better way of doing this, but this is my way of reassembling this piece. And it does take a while to navigate with the wires and PTFE tubes on this one. And before we mount it, just make sure the connectors are connected there. So there's a color black connector pin there for the right side, and the one on the left should be the white one. So just insert it properly, making sure that you don't crush any of the wires or anything underneath it. Be careful with that one. You don't want a damaged wire when reassembling this piece. So I'll let the video continue until we do mount the pieces. Nothing much happens after that, just points I've already made with the belt tension, and yeah, just follow along. Something I did hate when remounting the stepper motor was how hard it was for the side one there to be mounted. Mainly because I didn't have a magnetic Allen key or something that would help from falling off, because we had to do it multiple times until it did go through the right hole. So something that can go wrong with this one too is the wrong belt attached to the wrong stepper motor. With the right stepper motor, you do have to make sure it's attached to the idler pulley assembly, while on the left stepper motor, the one where it's completely all metal, you make sure the left stepper motor is attached to it. Some things I did notice reassembling and editing this part of the video. And here's the tougher screws to put in. And I'll let the video continue again, because this is kind of a bit of a long sequence that's very much self-explanatory of what's happening here. It was mostly just fumbling with the wires and connectors, plus screws, and a bunch more with the belt tension. It's pretty much the same stuff as what we did on the right stepper motor. We'll be doing it the same thing on the left side, which has a bit of an easier access, and the one with the white connector. So making sure that the orientation of that connector pin is in the right spot, right there, and we are good. Putting it back into place, making sure no wire is stuck in there, and we have a clear access to the mounting points over at the inner shell. And so after that long sequence, we get to finally see the assembly again. Just finalizing the last 2 screws there at the back. And earlier I was mostly looking at the wiring because you definitely don't want to cut any wires here. A lot of things can go wrong, so there's that. Here's a closer look of what it should look like. Mounted fine, looking good, and we should be able to put this back in the shell. Now, we do put this back into the shell after finalizing the pressure plates we did left off earlier. And if you did everything fine, it should look like that. And I slightly elevated the piece so that I can rotate and counter check. Putting some of these pieces back together with the right guides. So I think this rubber feet is meant so that the PTFE tube over there won't suffer from the heat coming from the stepper motor. Not entirely sure, but you guys can correct me. Flip this guy back over again and just checking if everything is aligned with the idler pulley and the driving wheel. So pointing out right there. Hopefully nothing is misaligned so that when the filament does go through, it can be fed inside the PTFE tube towards your extruder. Now, you can double check if there's a proper clearance so that when the filament is inserted, it should go to the right spot. And now we're finishing up with the bearing pressure plates so that everything is fixed and properly mounted. And I counter check with the screws if they are tight enough. So there's a right amount of force to use, but not too tight to a point where you break the plastic part, and be careful with that. And here we finish things up. Finally done. We try to look at the piece again one more time and put it back in the housing cover over here. So slowly put it in the right angle. Now this took multiple tries too. Same with the first one. It did look for a certain angle, and putting this back did take a while, but we eventually got it. And in this shot, we finally did put it in the right position. we can finally move on with mounting the filament sensor, which is on the side there. Okay. Next shot right here. And keep note of the right position for the PCB. You don't want to mess around with the wrong slot number for the filament sensor. Grabbing the connector right there before we plug it in the breakout board. Now again, I damaged my female connector pin, which I do remove later on and show you, but it's one of the bigger pain points I did with the disassembling with the hot glue stuff attached to it. Here's another look of the PCB, and I really hate the red adhesive they use on this one. And before I connected the connector pin, I noticed that the pin was bent, so I used a pair of tweezers, corrected the misalignment there, because no matter how hard I did push in the connector, it did not work. So this is one of the downsides with the smaller connector pins like this. You just have to be careful pretty much with dealing with this. And we finally attached it. So just be careful with that one. You can actually reapply some adhesive or hot glue so that it does keep in place. Remounting the PCB with the screws. In this part, I just double check the PCB if it's wiggling or not. Going to the last few steps, which are the filament sensors. So mount these guys properly. Any misalignments would definitely make this a bit harder to reassemble. So you can go over the video again if there is something not fitting properly in these parts. Getting these screws over here, which we'll be using for the mount. So finishing up, done with that, and try to cover it again. Lock it into place and flip it over. And in this part, we zoom out, going over the buffer mechanism cover, the outlet cover, and also the cable on the left side of the Ace Pro there. So making sure you connect the buffer mechanism in the right orientation. If these magnets over there don't connect to the magnetic sensor, it will prompt you with a lot more retraction error codes on the Kobra S1 or Kobra 3. So fits like a glove right there. Good. Don't forget to mount it with the 2 screws. But before we do, I do check out the springiness on the buffer mechanism there. Ideally, you do that with the PTFE tube so that you can have better hold on the buffer mechanism. And we finish off with the screws over there and then proceed with the other 4 screws that are needed. After all of the screws are done, we definitely hop into testing the unit out, which we'll be doing later. We're almost there. Pretty much just around 2 steps and pretty much confirmation if we did assemble the Ace Pro or Ace correctly. Also, there's 2 screws over here, just don't forget that, and another 2 down below with the rubber feet. We actually got confused on what angle we should be putting in these screws, but we defaulted to the original one. And the reason why we have it at this point was because if the screws can't grab onto the inner shell, it would have a hard time locking into the housing cover and the inner shell. I think by far this is one of the longest videos I've done, and it is exhausting to edit this, plus doing the voiceover. Very fulfilling, honestly. Learned a lot, saw the inner workings, and flipping this guy up so that we can finally finish the rubber feet here. Flipping it back up again and proceeding with the final cover that we left off. There you go, that piece. Pushing it back into place. Shouldn't take a lot of leg force too. As long as it snaps back into the original position. Right around there and then push over. Plus the 2 screws holding it. And we fixed it, hopefully. So close this up, lock into place, attach the tubes, connect the outlet, and counter check if it's loading things properly. So it should light the LED lights properly, and then just test out slots 1 to 4 if it does feed in and load out the filament properly. Because basically at this point we did disassemble a lot of stuff and assemble it back together, hoping that any kind of misalignments, loose screws, stuck filament is all done and over. But if you're still getting issues with that, maybe you can contact Anycubic support. Maybe there's a part you need replaced, maybe there's something that you need to check on, there's no signal line, PCB. So it's mostly the electronic side of things that we didn't dabble into, but most of the mechanical stuff and unmounting the PCBs, we did do that in this teardown and assembly of the video. So we can see perfectly that the filaments are loaded properly. I actually made a mistake on the slot 3. It was not aligned properly with the rollers there, but once fixed, it was perfectly good. So hopefully you fixed your Ace Pro with your Kobra S1, Kobra 3. And if you have any comments or suggestions for the next videos I do, please try to comment down below. Thank you guys for supporting the previous videos, and see you on the next one. Like and subscribe. Bye.